All right, so I want to start you off with this is your journal, or this is your Canvas page for today. I'm out and I'm very sorry, but these are the things that you needed to grab when you came in the door. You should have a small half sheet of green paper that has your Unit 6 I can statements on it. That's going to go in your journal. You will be grabbing your 6.1a journal entry. That's also a green piece of paper and it's a foldable. You're going to fold it in half. And then your Unit 6 homework packet. So I have you starting off to do your warm-up for today. However, I didn't correct the exit card from yesterday. So if you want to just jump down to, this is your exit card from yesterday. If you want to just do the exit card problem for today, I should get those corrected later on. Homework check. What questions do you have from yesterday's assignments or activities? The Desmos average rate of change. A couple of you left me a message saying that you weren't sure how to do that, so I'll make a quick video on those. But today we're going to do 6.1 product and quotient rules. You'll have a video posted here, completed journal. Your activity is 6.1 product and quotient rules. It's a Kahoot. I will post that for you. And then we have our homework, pages 1 and 2 of your homework packet. If you have your family syllabus letter, you can turn that into the sub, preferably Mrs. Banco when she comes in. This is your exit card. And then Addie Nelson, Kylie Cook, and Malia Rich, you still have not joined your Delta Math class. If you go to the module Monday, your links for our Delta Math are there. You need to join your Delta Math. Okay? All right, so let's get started with our lesson for today. So lesson 6.1. We always start off with a I can statement. Our I can statement for lesson 6.1a says, I can use the product and the quotient rule of exponents to simplify algebraic expressions. This comes right off of that half green sheet of paper. I won't always tell you the I can statement. Sometimes I'll make you fill that out yourself. Okay? So today I'm starting you off with that, but again, that came right off of your half green sheet of paper, your I can statements for Unit 6. So today we're talking about the product rule and the quotient rule. The product rule says that if you multiply two numbers with the same base, then you add the exponents. So I want to talk to you about what a base is. A base is the number or variable that's being raised to a power. So these, the letter D, that is your base. And these that have circles around them are your exponents. So when the base is the same, I have a D to the third power being multiplied by a D to the first power. Notice when there is no exponent there, I add a power of 1, multiplied by D to the second power. The rule says that you can add the exponents. Well, sometimes it's helpful to understand where the rule comes from, so that's what I'm showing you. We know that D to the third power is just D times D times D. Multiplied by D to the first power, that's D. Multiplied by D squared. Well, D squared is D times D. So I really have 1, 2, 3, 4, 5, 6 D's being multiplied together. So that becomes D to the sixth power. That's what it looks like when you expand it. So once you expand it, you can see that the rule, when it says you just add the exponents, remember to add a power of 1 if there's no power there, this becomes D to the power of 3 plus 1 plus 2, and 3 plus 1 plus 2 is in fact 6. So D to the sixth power. The other rule that we're going to focus on today is the quotient rule. The quotient rule says that if you're dividing two numbers with the same base, we actually are going to subtract the exponents. So here I have F to the fifth power. Remember, F is my base, 5 is my exponent, divided by F to the second power. f is my base, 2 is my exponent. So the bases are in fact the same. So the rule says that we subtract them. This becomes f to the 5 minus 2, which is f cubed. Now I want to show you where that rule comes from, because again, I believe that if you understand where the rule comes from, you have an easier time accepting the rule and just remembering it. It's just kind of intuitive. So f to the 5th power is the same thing as f times f times f times f times f. And f squared is the same thing as f times f. Well, remember rules of fractions, right? If you have 4 over 4, you know that that reduces to 1. These cancel out. So f divided by f is 1. F divided by f is 1. So really all you have is a denominator of 1 times 1. 1 times 1 is 1. And what do you have left in your numerator? F times f times f, which is f to the 3rd. And f to the 3rd over 1 is the same thing as f to the 3rd. So that is why this works. So we are going to expand the first couple and then just really rely on the rule. So our first one, example 1a, 3 to the 4th times 3 to the 3rd times 3 squared. The base is 3. So I'm going to expand that. 3 to the 4th, well, that's 3 times 3 times 3 times 3 multiplied by 3 cubed, which is 3 times 3 times 3 multiplied by 3 squared, which is 3 times 3. So how many 3's are you actually multiplying together? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this really is 3 to the 9th power. Now let's use our rule. Our rule says if the base is the same and we are multiplying, we just add the exponents. We keep the base and we add the exponents. 4 plus 3 is 7, plus 2 more is 9. So this becomes 3 to the 9th power. Okay, let's look at our next example. Our next example, 1b, is of the quotient rule. So again, I'm going to expand it. 4 to the 7th power, that is 4 times 4 times 4 times 4 times 4 times 4 times 4 over 4 to the 3rd, which is 4 times 4 times 4. So remember, 4 divided by 4 is 1. 4 divided by 4 is 1. 4 divided by 4 is 1. I don't even really write those ones there. I just am doing this for your brain to help you understand. And you know that 1 times 1 times 1 is just 1. So you have 1 in your denominator. How many 4's do you have left? Well, you have 4 to the 4th power. And 4 to the 4th power over 1 is the same thing as just 4 to the 4th. Okay? So let's use the rule. It says if the base is the same, the base is a 4, and you're dividing, you just subtract the exponents. 7 minus 3. Well, that does in fact equal 4 to the 4th. So you'll see, again, whether you expand it or you use the rule, you get the exact same answer. For example number 2, I'm just going to use the rule. I'm just going to use the rule. T to the 2nd power plus, there's no exponent here, remember to add a 1, t to the 1st plus t to the 2nd plus t to the 4th. 2 plus 1 is 3, plus 2 more is 5, plus 4 more is 9. This is t to the 9th. Okay. In example number 2b, using the quotient rule, we have some coefficients out front. Remember that numbers attached to variables are called coefficients. These are not bases. The bases are the numbers being raised to a power. So the base is r, r to the 4 minus 1. Well, 4 minus 1 is 3, but you can also reduce the 3 over 9. You can divide both the top and the bottom by 3. You get 1 over 9. 1 over 3, and then the numerator r to the 4 minus 1 is 3 again. Well, 1 times r cubed is just r cubed, or r to the third. So your final answer is r to the third over 3. Your next example, again, we have some coefficients. So you always multiply the coefficients, and then you use the base. So our coefficients, 4 times 3 times, this is a negative 1, times 2. And then my base, x, 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 and x. Remember, there's no exponent here, so that's to the first power. So I have a base of x that I'm multiplying, and I add my exponents. 2 plus 1 plus 2 plus 4. 4 times 3 is 12, times negative 1 is negative 12, times 2 is negative 24. Negative 24, x to the 9th power. Example 3b is a quotient rule. You have coefficients, 16 over 4. And then you use the rule that says if the base is the same, you subtract p to the power of 4 minus 2, q to the power of 7 minus 5. Well, 16 divided by 4 is 4. Or if you think about reducing it, it's 4 over 1. 4 minus 2, well, that's p to the second power. And 7 minus 5, that's q to the second power. So 4p squared q squared over 1 is just equal to 4p squared q squared. Our last two examples, you notice it's getting a little bit harder each time. Remember, we're going to multiply the coefficients. 3 times 3 times negative 2 times 2. Let's see, 9 times negative 4 is negative 36. Then we use the rule that says if the base is the same, I add the exponents. Y to the power of 2 plus a negative 1 plus a power of 2 plus a power of negative 2. So let's add these up. 2 minus 1 is 1, plus 2 is 3, minus 2 is 1. So I have negative 36 y to the first power, which is the same thing as negative 36 y. Our last example, 25 divided by 10. 25 divided by 10, those are my coefficients. I'm going to divide each one of these by 5 when I think about simplifying that. What are my bases? Well, I have j to the second power divided by j to the fifth, so 2 minus 5. I also have k to the 8th power divided by k to the 3rd power, 8 minus 3. So now I'm going to simplify my coefficients. 25 divided by 5 is 5. 10 divided by 5 is 2. And now I'm going to simplify my powers. J to the 2 minus 5, well, 2 minus 5 is negative 3. K to the 8 minus 5, well, 8 minus 3, well, 8 minus 3 is 5. So my final answer, 5j to the negative 3 power, k to the 5th power, all over 2. Now, eventually, you're going to learn a rule about negative exponents, but for right now, we're going to leave it just like that.